Let's talk about composition of functions. The word composition is talking about the constituents or the parts that something is made up of. So if we think about a composite shape, that's made up of two smaller or simpler shapes put together. And that's what we're doing with our composition of functions. We're taking two simpler functions and we're putting them together to make another function. Now I've got three functions here, f of x, g of x, and h of x. We can see they're all functions of x. Now, in our previous video, which if you haven't watched yet, make sure you go back and do, and I'll put the little tag up here so you can find it. We looked at substituting in numbers into our functions. So for example, f of 3. And that tells me that instead of having x, I'm going to substitute in 3 where the x was. So that gives me 3 plus 5, or 8. We also looked at substituting in an expression. So for example, instead of substituting in a number, we would substitute in 8 plus 1. Where the x is. So we would have, instead of x, we'd have a plus 1 plus the 5 on the end. And then we can simplify that, which gives us a plus 6. That's a quick review of what we did last time. Now, this time, instead of substituting in a number or a little expression, we're going to substitute a whole function into another function. So I'm going to start with my function, f of x. And then I'm going to leave a space where it's going to tell me what to substitute in. So right now my function is x plus 5. Okay, it's a function of x and we're substituting in something. Now instead of substituting in x or a number or an expression, we're going to substitute in the g of x function. So we're putting a whole function in where our x was. So let's take out that x. And where we had the x just here, we're going to put in a whole function, 3x minus 2. Minus 2. So we put that whole function in where the x was, and then our plus 5 on the end. So we can simplify that, and that gives us 3x minus 2 plus 5 plus 3. So we took the whole g function, and we put it inside of the f function. So we had our f function, x plus 5, but instead of the x, we took the x out, and we put in the entire g function, 3x minus 2. We can do that the other way around as well. We could start with our g of x function, our g function, and put the f function inside of it. So we've got our g of x function, and on the inside, we're putting in the f. So our g function started off being 3x minus 2. Now we're taking out the x, and we're substituting in the f of x function. Now when we substitute in a function, it can be really helpful, particularly if there is a coefficient, to put it in brackets. So x plus 5. We had our 3. We kept the 3. And then where the x was, we put in our whole f function, x plus 5, from here. And then we kept the minus 2 on the end. Now to simplify, we've got to expand our brackets first. 3x plus 15 minus 2 equals 3x plus 13. So we've taken a function, put it inside of another function. But you'll notice here that f of g of x and g of f of x are not the same thing. Here it was 3x plus 3, and here we have 3x plus 13. They are different. So the order of our composition is really important, and it will make a difference in the solutions depending on which function we put inside of which other function. So we've done some substitution here, and we can see we've taken the x out and we put a whole function in instead. So we've done f and g. Let's have a look at this h of x function. Let's substitute something into h of x. Let's say we're going to take the h function, and instead of putting x in, we're going to put the f of x function in, everywhere that x used to be. So we've got a couple of x's in here, so we have to be careful with those. Our first x is a square term. So we're taking our whole f function, and we're squaring it. Once again, it's important to go in brackets, so we remember to square the important part of the whole function. So instead of x squared, we now have the f function squared. Minus 2 times. Instead of x, we're putting in our whole f function, x plus 5. And then we have plus 1. So to expand this, we either use our FOIL rule by writing it as x plus 5 times x plus 5, or we can use the perfect squares expansion if you recognize that there, which is a squared, so our first term squared, plus 2 times a times b, or 2 times x times 5, so 10x, plus b squared plus 5 squared, that's 25, minus 2 times x, 2x, minus 2 times 5, minus 10, plus 4. Then we collect up our like terms. We have x squared, 10x minus 2x is going to give us positive 8x. 25, take 10, 15, plus 4 will be positive or plus 19. So we've substituted our f function into our h function. It gave us a couple of brackets to expand, and so on. Now we can substitute any function into any other function. It's always a good idea to substitute in brackets. We didn't substitute in brackets up here when we put in 3x minus 2, our g function, into our f function, because there was no multiplication. But you could still substitute in brackets there if you wanted to remind you the bracket's really important, particularly when we have an expression or a negative number. And our functions, because they're composed of two or more functions, they're called a composite function. You can have a composite function where it's more than two functions. You could have f of g of h of x, something like this. F of g of h of x. We can stack our functions inside of each other. So we started with our f function, and then we put the g function in, and then we put the h function inside of that. But we'll look at that in a different video because that's a little bit more confusing.